Analytical epidemiology. Analytical epidemiology is type of observational epidemiology. In analytical studies, we discuss case control and cohort study. Basically, analytical epidemiology is the continuation of descriptive epidemiology. We formulate hypotheses at the end of descriptive study. We test this hypothesis in analytical studies. We'll discuss this session according to following learning objectives. We will define analytical studies. Then we will describe the types of analytical studies like case control study, cohort study, then where they are applied. In the end, we will summarize the session. Let's start with the definition. What is analytical study? Analytical study is a type of observational study. No intervention is being done in analytical studies, so it is observational. And in analytical studies, we test the hypothesis. Testing of hypothesis is done in analytical studies. We formulate the hypothesis in descriptive studies and test in analytical studies. They may be prospective or retrospective. What are prospective studies? Prospective studies or forward studies, or in prospective studies, we move from present to future. And retrospective study, they are backward studies. In retrospective studies, we move from present to past. Oh, there are two main types of analytical studies, case control study and cohort studies. We discuss case control study. It's individual based study. We discuss case and control from the population. We select case and control from the population. So we select a population, then we will select cases and controls. What are cases? Cases are those who have the disease under study. Controls are those who don't have the disease under study. We'll see the exposure in case and in controls. We'll see how many cases are exposed to a risk factor, how many cases are not exposed to a risk factor under study, how many controls are exposed to a risk factor under study, and how many controls are not exposed to risk factor under study. So we'll move from present to past. So we have seen that some cases are exposed and some are not exposed. So this means the risk factor which cause the disease doesn't cause the disease in 100% of population or 100% of individuals. And controls, risk factor may be present, but a person is not diseased or person is not infected. So what are various steps of case control study? First, selection of cases. We have to select the cases. We have to select the control. Then matching is done. Certain variables of case and control should be same. Then we will measure the exposure. In the end, we will do analysis of case control study. How we will select the cases according to diagnostic criteria and according to eligibility criteria. What is diagnostic criteria? Cases are diagnosed. It is case control study is done in rare diseases like in cancers. So we take the cases of same stage or same grade like grade 1. If we select the cases of different stages or different grades, outcome varies, outcome is different. Like we select a case of lung cancer at stage 4 or grade 4, and we select other case at stage 1. Outcome is different in both the cases. So we have to select the case of one stage or of one grade. Then we have to follow eligibility criteria. We have to select the cases in a specific time period or cases of a specific time period. We must be specific time. Like we select cases of lung cancer of 1990 or 2020. They all should belong to one time period because diagnostic criteria changes from time to time. There are new interventions. There are new developments in diagnosis. What are the sources of cases? Cases are selected from hospitals. Major source of selection of cases is hospital, or they are selected from general population. We get the data from hospitals because hospitals have the record. And from general population, people know that they are diseased. They know about their disease. We'll select controls. What are controls? Those who don't have the disease under investigation. Like we are doing a study, case control study of lung cancer and smoking. Cases are those who have the lung cancer, and controls are those who don't have the lung cancer. They may have other disease. So we will select them. From where we will select them? We can select them from hospital. We can select them from general population. We can also select them from family. But remember one thing, in genetic diseases, controls are not selected from family. This is a common MCQ. We will not select cases of controls of a family in genetic diseases. So we have selected cases, we have selected controls. What will we do now? We'll do matching. What is matching? There are variables involved in a study like age, gender, time. Cases and control are different with respect to certain variables. They may be same with respect to certain variables. We have to match them. Like matching is defined as selections of controls with respect to cases in such a way that they resemble with them with certain variables and they may differ with them. So they have to resemble, they have to differ. Like what will be the major difference? Major difference will be the disease. This will be absent in controls. So matching is done. Why matching is done? Matching is done to remove bias. Which type of bias? Confounding bias. So we do matching to remove bias in case control study. Like age can be a bias in lung cancer. Alcohol can be biased in a study of smoking and esophageal carcinoma because esophageal carcinoma can be caused by both alcohol and smoking. It can affect the outcome. It will cause confounding. To remove confounding, we'll do matching. So we'll take the example smoking and esophageal carcinoma. We will select cases and controls like they are not alcoholists. We can select smokers only. Cause alcohol can cause bias. Alcohol can cause confounding. This is matching. Why this is done? Then we will measure the exposure of cases. Cases are those who have the disease. They are suffering from disease. They are suffering from disease, but we have already discussed that risk invades and causes the disease. This is exposure. We have discussed that it takes time. Development of disease takes time. Development of chronic diseases takes time. It may take 20 years, 30 years. So we'll measure the exposure rate in cases. How we will measure? Because they are already suffering from disease. We can interview. We can do interviews by interviewing, by questionnaire. We will ask questions. We will investigate from them and measure the exposure. As controls may be exposed, so we will measure exposure of controls. Exposure of cases should be greater than controls. Then we can say that there is association between risk factor and disease. So what will we analyze? What will we measure in case control study? We can't measure incidence. We can't measure prevalence. We will measure exposure rate. Exposure rate of case and control. If exposure rate of case is greater, then we can say that there is association between risk factor and disease. Then we will measure odds ratio. Odds ratio is strength of association, but indirect strength of association. Because direct strength can be measured by incidence. Incidence can't be found, can't be measured in case control study. So we'll measure two things, exposure rate and odds ratio. So let's discuss the scenario. There are 100 cases of lung cancer. We have selected 100 controls. Among 100 cases, 30 were smokers, or we can say that 30 were exposed. And among controls, 10 were smokers. We have to draw 2 by 2 table to see the association between exposure and outcome. So how will we draw the 2 by 2 table? There are cases and there are controls. We'll compare the exposure. Positive means exposure and negative non-exposure or non-exposed. So there is A, there is B, there is C, and there is D. We fill the boxes. Now we see that there are 100 cases. We will write 100 below the cases, and there are 100 controls. Among 100 cases, 30 are smokers, so 30 are exposed, and 70 were non-smokers. How we calculated 70? There are 100 cases. We subtract 30 from 100 and put remaining cases in non-exposed. This means that among 100, 30 were smokers or 30% were smokers and remaining were non-smokers. Okay. Among controls, 10 were exposed or 10 were smokers. So we subtract 10 from total controls. Answer is 90. We will write 90 here. Easiest way to formulate a 2 by 2 table in case control study that we move from upward to downward or from downward to upward, like in this direction. 30 were exposed, remaining were non-exposed. 10 were exposed and remaining were non-exposed. Remember this thing. There is a confusion in creation of 2 by 2 table. First, we have to diagnose the study. In case control study, number of cases is more than number of exposed people. Then we will write cases in exposed person in A and remaining one non-exposed in C. So now we will calculate exposure rate of case. There were total 100 cases, 30 were exposed. So we divide exposed cases with total number of cases and multiply them with 100. Exposure rate will be 30%. This means that 30% of cases or 30% of people who are suffering from lung cancer were smokers. I will calculate exposure rate of controls. 10 controls were exposed, or 10 controls were smokers. Total number of controls was 100. We divide exposed controls with total number of controls and multiply it with 100. Answer will be 10%. What will be the formula? We know that 30 people, they are exposed. So we write there A and total number of cases, A plus C. And then we see that 10 controls were exposed. It is B. So we divide B with B plus D and multiply them with 100. We'll calculate the percentage. As we have seen that exposure rate of cases is greater than exposure rate of controls. So we can say that there is association of smoking and lung cancer in our study. They are associated with each other. Now, association is being established. We have to see the strength of association. We will measure the strength of association from odds ratio. So what is odds ratio? Odds ratio is strength of association, indirect strength of association in case control study. So how will we calculate odds ratio? Formula of odds ratio, we have to make a cross like in 2 by 2 table. There is A, B, C, D. We will multiply A with D and we'll multiply B with D and divide them. So formula will be AD over BC. What is A in our study? A is 30 and D is 90. We'll multiply exposed cases with non-exposed controls. So we'll multiply 30 by 90 and we'll multiply exposed controls with non-exposed cases. Remember the cross, AD over BC. So we'll multiply with 30, 90. Then we'll multiply B with C. What was B? 10. And what was C? 70. We'll multiply them. Answer will be 3.9 roughly. What will this answer indicate, or how will we interpret this odds ratio? Interpretation is mandatory. 3.9 means that cases are exposed people are 3.9 times greater risk of developing lung cancer. They have greater risk of development of lung cancer. So we'll interpret it. Smokers have 3.9 times greater risk of developing lung cancer than non-smokers. So there is association between smoking and lung cancer. We can intervene now. After this kind of study, we will do intervention to stop smoking. We'll do legislation. We will create awareness. We will educate people that you are at greater risk. You are at 3.9 times greater risk of developing lung cancer than non-smokers. This is the significance of calculating odds ratio. That's why we perform case control studies. Then there are various advantages and various disadvantages of case control study. What are the advantages? It is easy. Oh, it is easy. It is easy to go back in past and check the association of outcome and risk factor in a retrospective way. It is cheaper. Less money is required. Time duration. It takes less time. These are advantages. There are no ethical issues because we are not doing any intervention. Major disadvantage or major drawback of case control studies bias, like memory bias, confounding bias. That's why we do matching. Always remember, bias is major drawback of case control study. This can be a common university question. And there are no ethical issues. What will calculate? Odds ratio. This is advantage. Disadvantage. No incidence is calculated. Or we can't measure incidence. We can't measure relative risk then. So case control study is a retrospective type of analytical study. We select case, we select control. We do matching. We measure the exposure, and then we do analysis. We will calculate exposure rate and establish association or risk factor and disease. We will calculate odds ratio and see the strength of association. Now we'll discuss cohort study. What is cohort study? It's analytical study. This is prospective analytical study. We'll see relation of exposure and outcome. We'll move from present to future. Cohort studies are done after case control studies. Cohort studies. What is meant by cohort? Cohort is a group. We select a group of people. Which kind of group? Who share common features in a specific time period or in a specified time period. Like birth cohort, cohort of doctors, cohort of engineers, cohort of nurses, cohort of medical students, cohort of fourth year MBBS, cohort of people of cell court. There is a group, this is a group who may have common features in a specified time period. Analytical study, what we'll see? Association. Association of what? Risk and disease, but in a prospective way. How risk factor causes a disease. We'll monitor cohort of people. We'll do monitoring. We'll observe them. We'll not intervene, but we will observe. And at the end, we'll see the result. How many exposed people have developed the disease. We compare exposed people with non-exposed people. They may develop the disease caused by other factors. In the end, we'll analyze how we'll define cohort study or what is the proper definition of cohort study. It is asked in exams. It is asked in university. So it's a prospective study in which we move from exposure to outcome and see the association of risk factor, and disease. So, oh, this is cohort. Cohort must be disease free. They may be exposed, but they are not diseased. We divide this cohort into exposed cohort and non-exposed cohort. Exposed risk factor is present in exposed. It is absent in non-exposed. Then sufficient time period is required. We will see how many exposed people develop the disease, how many exposed people are disease free, how many unexposed people develop disease, and how many unexposed people are disease free. We'll see that. We move from present to future. It's a time taking process. Cohort study takes time. Like when we divide them, we'll do follow up for years. It can take years, it can take months. So, greater money is required, time is required. In cohort study, in the end, we'll measure the incidence. This is the benefit of cohort study. So, what are various types of cohort study? There are three main types of cohort study: prospective cohort study, looking forward study, in which we move from present to future. There is retrospective cohort study. You may be thinking, we discussed previously that cohort study is a prospective study. How we can say that it's a retrospective study? We definitely move from cause to effect, but we'll go back to past, establish the association, or establish the risk factor, then we will move from past to present. So in retrospective study, we move from past to present. Like in study of cancers, we want to see association of uranium with lung cancer. Cancer is already present. We move from present to past and see whether exposure with uranium is present or not. We'll establish exposure, then we will move forward from past to present. This is retrospective cohort study. Third type is mixed cohort study. First, we'll move from present to past. Then we'll move from past to present. Then we'll move to future. This is mixed cohort study. So these three types, they all move from exposure to outcome. But there may be a factor that we have to move from present to past. Then we'll move from past to present. This is retrospective cohort study. What is prospective cohort study? Let's discuss it in detail. Association of smoking and lung cancer. We move from exposure to outcome in forward direction. People are exposed, people are smokers. We'll follow up them, we'll monitor them for a certain time period. In the end, we'll establish the association between risk factor and outcome. What is retrospective cohort study? You can take example of uranium and lung cancer. So, lung cancer is present. We'll move to past to see the exposure from uranium. We'll move to past. We'll establish risk factor. Then we'll again move from past to present. This is retrospective cohort study. What is mixed cohort study? We move from present to past to establish association or to establish this factor. Then we'll move from past to present. Then we'll move from present to future. Like in the study of uranium and lung cancer, we move from present to past to see the exposure. Then we'll move to present and said that uranium or exposure to uranium causes lung cancer. Then we'll move forward or in future to see the complications, to see the severity, to see the outcome, to see the mortality due to lung cancer caused by uranium. This is mixed cohort study. We'll discuss various steps of cohort study which are involved in conduction of cohort study. Like selection of cohort. We will select a group. Then We'll measure the exposure of this group. Then we'll select the comparison group or select the control group. Then we'll do follow-up. Follow-up is time-taking process in cohort study. People may lose follow-up or we may lose follow-up. This is called attrition problem. This is a common problem of cohort study. Then we'll do analysis. We'll calculate incidence, relative risk, attributable risk from cohort study. So let's discuss them one by one. How we'll select a cohort? What is cohort? A group. We'll select an exposed group like smokers. From where we select this group? From general population or from population. Smoker is a specific group in a population. We'll select it. Then we'll measure the exposure. How we will measure the exposure? We can take interview by questionnaire. We can also do lab investigations. Like if we have taken a cohort of smokers to see the association of smoking and ischemic heart disease, we can do ECG, we can do chest X-ray. If a member of cohort is suffering from disease, we will exclude it. Remember this thing, cohort must be disease-free at the start of study. Then we'll select comparison group. We can select internal comparison and external comparison. So we can select internal comparison and or external comparison. Members of cohort may vary in exposure. Some will have greater exposure, some will have lesser exposure. In case of smoking, some smoke 20 cigarettes, some can smoke 10 cigarettes, some can smoke 5 cigarettes per day. Outcome will be different in those who are smoking 20 cigarettes, then those who are smoking 10 cigarettes, then those who are taking 5 cigarettes. Outcome depends on dose. So it will be severe in those who are smoking 20 cigarettes. So we can do internal comparison. We can do comparison of 20 cigarettes and in 10 cigarettes. All outcome varies. So this is internal comparison. We can select cohort or internal group or control group from this same cohort. Those who are less exposed are taken as comparison group. Then we can take external comparison. Sometimes this is not possible. Our internal comparison is not possible. So we have to take external comparison, like we compare smokers from non-smokers. We'll see how many smokers develop the disease, how many non-smokers develop the disease. After selection of comparison group, we'll do follow-up. How we will do follow-up? By contacting them. Contact by phone, email, or questionnaire. So we'll do investigations after a certain time period to see whether they have developed the disease or not. We'll investigate, we'll do lab tests. So one major problem with cohort is loss of follow-up, attrition problem. People may migrate, may die. So we'll select a larger group. Cohort is taken in thousands. We'll select this larger group. So at the end, if some people lose follow-up or some people leave the study, and in the end, we must have sufficient people or sufficient sample to calculate the data, to analyze the data. So we'll follow up them. We can do follow for years. Like in case of smoking and lung cancer, we know that lung cancer develops after 20 or 30 years. So we have to follow smokers for 20 or 30 years. In case of ischemic heart disease and smoking, we have to do follow up for years. In case of cancers, we have to do follow up for years. So it is time-taking process. It's a hectic study. Greater amount of money or greater budget is required to conduct this cohort study. We do follow up. Then, in the end, we will analyze We'll compare the exposed group with non-exposed group. How will we will analyze? We can measure incidence. This is a major advantage of cohort study. We can measure incidence. Then we will measure relative risk or strength of association. Then we will measure attributable risk. What attributable risk indicates? It indicates specificity of association. So incidence measures the rate. Relative risk measures the strength. And attributable risk measures the specificity, whether this respector is specific to disease or not. So let's measure them. Suppose 100 people were exposed to smoking, 100 were non-exposed. 100, though, those 100 who were smoking, among them 30 developed lung cancer. And among 100 non-smokers, 10 developed lung cancer, 10 developed disease. In cohort study, number of exposed people is greater than number of diseased because exposed people are divided into diseased and non-diseased. Number of non-exposed people is greater because they are divided into diseased and non-diseased. So we'll write diseased here and non-diseased here. People who are exposed and non-exposed. We already said 100 people were exposed to smoking. So there were 100 exposed people and 100 people were non-smoker. First we write A, B, C, D. Most of the time students make a mistake. They don't write A, B, C, D in 2 by 2 table. It is mandatory to write. Then we will divide exposed people into disease and non-diseased. 30 developed disease. So we subtract 30 from 100. Remaining are 70. So 70 are non-diseased among smokers. Then 30 were diseased among smokers and 70 were non-diseased among smokers. Total number of smokers is 100. 10 non-smokers developed lung cancer. We write 10 here. And if we subtract 10 from 100, remaining is 90. 90 non-smokers did not develop lung cancer. As the table shows, that smokers have a greater tendency to develop lung cancer as compared with non-smokers. Cause only 10 non-smokers develop lung cancer after a certain follow-up or after a certain time period, but 30 smokers develop lung cancer. So now we will measure incidence. Incidence among exposed. Total 30 exposed people develop lung cancer. So A were exposed. Total number of exposed were A plus C. A cases are those who are diseased. 30 people develop lung cancer out of 100. How we'll calculate incidence? We'll multiply this by 1000. Always remember, multiplier of incidence is 1000. What will be our answer? 300 per 1000. And now we'll measure incidence of non-exposed. As we can see in the table, 10 non-exposed people develop the disease. So we'll write C over C plus D. C is 10, C plus D is 100. We'll multiply this by 1000. Our answer will be 100 per 1000. What this means? That among 1000 smokers, 300 develop lung cancer according to our study. Among 1000 non-smokers, 100 can develop lung cancer in our study. So incidence is greater in smokers. There is association between lung cancer and smoking, or there is association between risk factor and smoking. We can see we'll move from in this direction while constructing 2 by 2 table in cohort study. Now we'll measure relative risk or strength of association. We'll see whether our association has some strength or not. We'll calculate by this formula incidence among exposed divided by incidence among non-exposed. What was incidence among exposed? It was 300. What was incidence among non-exposed? It was 100. So our answer will be 3. So we will interpret this relative risk. How we can interpret? There are certain boundaries, or there are certain points, or we can say that there are certain cutoff points. If a relative risk is greater than 1, there will be positive association. We can say that there is positive association between risk factor and disease. If relative risk is equal to 1, we can say that there is no association because incidence among exposed and non-exposed is same. There is no association. In certain studies, relative risk is lesser than 1. It indicates there is negative association. Risk factor is not causing the disease. There must be other risk factor. So how will we interpret? Remember, 1 indicates no association, plus 1 positive association, or greater than 1 positive association, lesser than 1 negative association. So in our study, relative risk is 3. We can say that there is positive association between smokers and disease, or there is positive association between risk factor and outcome. It causes the disease. How will measure attributable risk? Attributable risk shows specificity. We will subtract incidence among exposed from incidence among non-exposed. Then we'll divide this from incidence among exposed. This is the formula. We'll multiply this by 100. Always remember the multiplier. Multiplier of incidence was 1000. Multiplier of attributable risk is 100. There is no multiplier in relative risk cause it's the ratio. We are comparing incidence among exposed and non-exposed. So we'll not multiply it. But in attributable risk, we are finding the burden. We are trying to find percentage. So we'll multiply it with 100. What was incidence among exposed? It was 300. 100 was incidence among non-exposed. We'll divide this by 300. First, we'll divide 200 with 300. It will be 66.6% roughly. How we will interpret, as we have said, that attributable risk measure the specificity of risk factor and disease. Now we can say that in our study, 66.6% of disease is caused by the risk factor under study. Remaining may be other factors like aging, environmental factors, genetic factors. They may affect the outcome. 66% of disease is caused by risk factor. If attributable risk is equal to 0, there is no association. If attributable risk is greater than 0, there is positive association. Our attributable risk is greater than 0. If it is less than 0, there is negative association. It is different from relative risk. Cutoff value of relative risk was 1, but cutoff value of attributable risk is 0. Greater than 0, positive association. Lesser than 0, negative association. 0, no association. So we have measured incidence. Incidence in our study showed that smokers have greater incidence of developing the disease. So there was association. Then we calculated relative risk. It was greater than 1. There was positive association. Our association is strong. We calculated attributable risk or specificity. It was 66%. So association was positive. We will interpret them. So, in the end, we'll summarize the session. Before summarization, we can discuss advantages and disadvantages of cohort study. What are main advantages? Main advantages: incidence, relative risk or strength of association. There is lesser bias. What are disadvantages? It is time taking. Major disadvantage in cohort study is attrition, loss of follow up. Oh, people may die, people may migrate. So, sample size will decrease gradually in cohort study. That's why we take a larger sample in cohort study. This is a MCQ. What is attrition? It is loss of follow up. What is major disadvantage of cohort study? Attrition problem. There may be ethical issues, as we have discussed. We have to impart health education in smokers. It is unethical to monitor smokers for years, and see how they will develop lung cancer. We can't leave them to die. These are major advantages and disadvantages of cohort study. Now, what we have discussed in the session, we have discussed analytical studies. We have discussed there are two types of analytical studies: case control and cohort study. We have discussed case control study is retrospective study. We have discussed cohort study is prospective study. We have discussed various steps of case control study and cohort study. We move from outcome to exposure in case control study. We have seen we select case, we select control, we do matching to reduce confounding. We'll measure the exposure. In that, we analyze. So, what are major findings of case control study? Odds ratio. What are major findings of cohort study? Incidence, relative risk, attributable risk. We discussed there is problem or there is bias in case control study. We discuss there is attrition in cohort study. We discuss cohort must be disease free before the start of study. We move in forward direction. So we also discussed various types of cohort study. We discussed there are three types of cohort study: prospective cohort study, retrospective cohort study, mixed cohort study. In the end, we made 2 by 2 table. Remember one thing: in case control study, we divide cases into exposed and non-exposed. So number of disease people is greater than exposed in case control study. And in cohort study, we divided cohort are exposed into diseased and non-diseased. So exposed people, a number of exposed people are greater than diseased and non-diseased. This is distinguishing feature of cohort and case control study. We draw 2 by 2 table on this base, or we diagnose case control study and cohort study on the basis of number of cases and number of exposed people. So that's all.